This is the 2-port injection, VIN F, and multi-port VIN 8 diagram. So this applies to both of them. The circuit operates the same way on the TBIs. They're just wired a little differently. So starting off, we've got our engine control module down here. We have our fuel pump relay here. And then we have our oil pressure sender switch combination. This is the 3-wire sensor. And then you have your 12-volt source up here, and then of course down here we've got our fuel pump. So if you're not aware of how wiring diagrams are drawn, written, or read, I guess, these little circles here indicate a splice. That means that this gray lead and this gray lead are spliced together somewhere in the harness. Same thing, all of these orange wires are spliced together. They all come from the same place. So if I put 12 volts to this guy, hot at all times, right? So if I hook the battery up, this is going to have 12 volts. So don't worry about these two guys over here. What's important here is that on pin A of the relay, as soon as we have that battery hooked up, we have 12 volts there. It's ready to go. If you're not familiar with how a relay actually works, when we have our coil side and we have our armature side. So this switch here, this is internal to the relay, this is the actual armature. In a normal condition without the coil being energized, pin C is, let's call it a completed path. So that's going to be the little, it's a red wire, it's normally found on the driver's side, it's a single spade, and there's a lot of people that post and say, hey, what's this, do I have to have this hooked up? The only thing that's there for is to apply 12 volts to it, and then you can kick the pump on. It's part of the troubleshooting process. So when this coil gets energized by the engine control module after you turn the key forward, once power goes down this dark green white wire and across, this armature is going to close. So that's going to provide 12 volts from inline fuse number 2 down through the relay, down here, and down to the fuel pump. So if for some reason your fuel pump is compromised, or your fuel pump relay is compromised, these splices provide a parallel path. So if my fuel pump relay is shot, you can trace from your inline fuse number 2 down to that splice, over, down through the oil pressure switch, which is closed with normal pressure, down to the fuel pump. So that's how we get 12 volts. That very clearly states switch powers fuel pump if the ECM fails. So if the ECM sees a fault on this relay control, or your relay is shot, then yeah, you're going to be relying on the oil pressure switch. So the only possible way for the engine to be shut down at a loss of oil pressure or a fault in this switch is if your fuel pump relay is already compromised. If you're relying on this solely, and you will see extended crank times. It takes a couple seconds to build the pressure needed to close that switch and actually kick the pump on. So if you look down here at the bottom of the diagram, we have, based on ignition power, right? So when we turn the key on, fuel pump relay control energizes the relay for 2 seconds after the key's in run, then continues to energize as long as there are ignition pulses. So our ignition pulses, that comes from our pickup coil in the distributor, and that also feeds into the ignition control module, which feeds back into the ECM. So as soon as you start cranking, this is back in a normally functioning system. As soon as you start cranking and that distributor starts spinning and that pickup starts giving off a signal, this is energized. 12 volts until you shut the car off, right? Once we shut the vehicle off, this is no longer energized. This armature snaps back over to the test connection. So yes, the relay does play a role in the prime, but that comes from the ECM. So whether you do have a prime or you don't have a prime, it doesn't really matter. It's just going to extend your crank time. Not having a prime function is the same as running just off the oil pressure switch. So the other thing too is, if your switch fails, let's cover this whole guy up. If your oil pressure switch has failed and your relay's still working fine, the only way that you're going to know is you're going to see a pressure issue, right? You're going to freak out because, oh no, I've got, normally when it's disconnected, if it faults open, you would see 99 psi or max, whatever your gauge is. So in this scenario where we don't have an oil pressure sending unit or switch, power would go through the fuse, down through the relay, obviously, because this would be energized, so this guy would snap over, and then you trace that down to the fuel pump. So whether this is here or not here, it doesn't matter. It's not a safety device. It's not a interrupt. It doesn't save your engine. If for some reason you've experienced that, that's because your relay is faulty or your relay control is faulty. So here we've got our fuel pump relay, and then down at the oil filter we've got our actual sending unit. So if I take this guy and disconnect it, it's going to do a couple things. I'm not going to have oil pressure reading on my gauges, obviously, but it'll still allow the engine to run. So what I've done in the past when I didn't run an oil pressure sending unit, I tucked that connector away, and I used to use it for troubleshooting. So you can actually jumper 2 pins on the connector to run your fuel pump. So I'm going to go ahead and start the car real quick. Doesn't like to run when it's cold. All right, so you guys saw I've got 79 PSI of cold oil pressure. So I'm gonna reach down before this gets too hot. I'm gonna disconnect that thing. Idea. Hey, look at that. My car's still running. That's weird. Now I'm showing you 99 PSI of oil pressure. Why? Because it's not hooked up. Now if I take this relay and I disconnect it, I'm going to shut off the fuel pump. It's no different than disconnecting or removing the fuse for the fuel pump. So when that relay's disconnected and the switch has failed, sure. So the only way that you would actually have a shutdown of the engine is if your relay's already toast and it's running on the oil pressure switch. The oil pressure switch will continue to keep the fuel pump circuit alive. The oil pressure switch will continue to keep the engine running. So what you'll see if your fuel pump relay is bad is you'll have extended crank times. That's pretty much it. That's the only difference. Whether the pump primes or doesn't prime, it doesn't really matter. It just reduces the crank time. So I'm going to take this guy and shut it off. I'm going to grab my meter and show you oil pressure switch fun. There's the meter. It's really hot. See if I can burn myself. There's my 12 volts. So, of course, all my wires are covered in oil. 3 different wires on here. Power, ground, and then I believe it's tan. It's a little mucky. Anyway, tan goes to the gauge. So if I take this guy, I'm going to unplug my fuel pump relay, just for fun. Oh, come on. Get you unplugged. Remove all this. Don't catch anything. Let's see if we get the fuel pump prime. No prime. Weird. It's almost like there's no power going to the fuel pump. Very carefully plug this guy back in without burning my hands too much. All right. Relay's disconnected, oil pressure switch is hooked up. Now we'll get an extended crank. Look at that, I'm showing 0 PSI for oil pressure. Now that it's hooked back up. This guy back up. Actually, you know what? We'll shut it down first. You guys heard the extended crank. That's how long it took for the oil pressure switch to see pressure and to close the switch. Hook this guy back up. All right, so now that the oil pressure switch and the fuel pump relay are both hooked back up, we have prime, and when I start it, it's going to start a lot quicker. Disconnecting the switch or the switch failing does not prevent the car from starting.